Hello everyone. In today's video, we are stepping into the world of Pandas, the powerhouse library for data manipulation in Python.
Specifically, the creation of DataFrame objects from other data structures in Python and from external sources. We also will talk how to collect data from API, read and save DataFrame.
Let's delve into the intricacies of working with DataFrames in Pandas.
Welcome to Data Science Cheat Sheets channel, transforming lines into limitless creations.
Pandas is an open-source data manipulation and analysis library for the Python programming language. It provides data structures and functions needed to efficiently manipulate large data sets. Installing Pandas in Python is a straightforward process. Open your command prompt or terminal and run the following command. This will download and install the latest version of Pandas from Python package index PyPI. That's it. After the installation is complete, you can start using Pandas in your Python or Jupyter Notebook environment. If you encounter any issues, double-check your installation steps or consult the official documentation for Python or pip. The key data structures in Pandas are series, a one-dimensional array-like object that can hold any data type. It is similar to a column in a spreadsheet or a single column in a data frame. Index. The addition of the index class makes the series class significantly more powerful than a NumPy array. The index class gives us row labels, which enable selection by row. Depending on the type, we can provide a row number, a date, or even a string to select our row. DataFrame. A two-dimensional table with rows and columns similar to a spreadsheet or a SQL table. It is the primary data structure in Pandas and is used for most data manipulation and analysis tasks. A data frame has two indexes. Typically, the column index is a list of strings, variable names, or less commonly, integers. Typically, the row index might be integers for case or row numbers, strings for case names, or datetime index or period index for time series. For more about variables and integers, be sure to check out this video.
Creating a Pandas data frame from a Python object. To begin, let's explore what a series is in the context of Pandas. It is like a column in a spreadsheet or a single column of a table. Making a data frame object is an extension of making a series object. It will be composed of one or more series, and each will be distinctly named.
Please be aware that we are establishing the seed here to ensure reproducibility of the outcome. The keys are the column names, and the values are the contents of the columns. Note, if we want to turn a single series object into a data frame object, we can use its toFrame method. To illustrate the process of creating a data frame from a list, let's consider an example with a list containing information about individuals, such as their names, ages, and occupations. We'll create a data frame using this data. In this example, the pd.dataframe constructor is used to convert the list into a data frame. The columns parameter is employed to specify the names of the columns in the data frame. You can replace the sample data with your own data set, adjusting the number of columns and rows based on your requirements. In cases where the data isn't a dictionary, but rather a list of dictionaries, we can still use pd.dataframe. Each entry in the list will be a dictionary, where the keys of the dictionary are the column names and the value of the dictionary are the values for that column at that index. In fact, pd.dataframe also works for the list of tuples. Note that we can also pass in the column names as a list through the column argument. Each tuple is treated like a record and becomes a row in the data frame. We also have the option of using pd.dataframe with NumPy arrays. This will have the effect of stacking each entry in the array as rows in a data frame.
Creating a Pandas data frame from external sources. Pandas makes it seamless to import data from various sources. The following specific functions provided by Pandas can be used to import data from various formats into Pandas data frame. For CSV file, for text format, for LVM format, for Excel format, for JSON format.
Please note that sometimes you need to specify the delimiter. The delimiter parameter is used to specify the character or sequence of characters that separates the values in each row of the file. In the pd.read CSV function in Pandas, the SEP parameter specifies the delimiter used in the CSV file to separate the fields, columns. By default, the CP parameter is set to comma, assuming that the file is a comma-separated values CSV file. Here are some other arguments.
To read compressed CSV file into a Pandas data frame, you can use compression parameter in the code line. Additionally, if your file has other characteristics like a header row or different encoding, you may need to use additional parameters such as header and encoding to properly import the data. Always refer to the Pandas documentation for more details on available parameters.
To load a data frame from a MySQL database in Python, you can use the Pandas library along with a database connector such as MySQL connector or PyMySQL. All the code lines featured in this video are available in the Jupyter Notebook down below in the description. Note that we are not limited to reading in data from files on our local machines. File paths can be URLs as well. Here is the example to read CSV file, which is stored and shared on Google Drive.
To get data from online resources, such as API, application programming interfaces, you can use the request library in Python to make HTTP requests. The exact process depends on the API you're working with, as different APIs have different authentication methods, request formats, and endpoints. Here's a general example of how to make a simple GET request to an API and convert the response to a Pandas data frame. This is another basic example, and you might need to include additional parameters, headers, or handle authentication, depending on the specific API documentation. Additionally, consider error handling and security practices, especially when dealing with sensitive data or APIs that require authentications.
Saving a data frame. Saving a Pandas data frame into various file formats is straightforward, as the library provides convenient methods for different formats.
Here are some examples. Saving data frame to CSV file with comma-separated values. Saving data frame to Excel file.
Saving data frame to JSON file. The orient parameter defines the format of the JSON. The records parameter creates a list of dictionaries. The lines parameter equals true writes each record, row, as a separate line in the JSON file.
Pandas doesn't have a built-in methods for saving XML, but you can use external libraries, such as XML to dict or dict to XML. Make sure to install them first, using the following pip codes.
Saving data frame to SQL. Use the appropriate connection string for your database. The if exists parameter can be fail, replace, or append, depending on your needs.
The presented examples cover various file formats, but keep in mind that specific formats might have additional options or parameters you can explore in the Pandas documentation.
Adjust the file names and paths, table names, and connection strings based on your requirements. Pandas library is built on top of the NumPy library and is an essential tool for data scientists, analysts, and engineers working with data in Python. It provides a high-level interface for data manipulation and analysis, making it easier to work with structured data in a more intuitive and efficient way.
We will talk about Pandas functionality in details in the future, upcoming videos. All the code lines featured in this video are available in the Jupyter Notebook down below in the description.
Thanks for being a part of our journey today. If you enjoyed the content, hit that subscribe button. By subscribing, you not only show your support for the channel, but also ensure that you never miss out on the exciting content we have in store.